All right, Algebra 1, hello. We are back. We're going to start into Unit 5 here, which is called Polynomials. Okay, it's a big math word. Basically, just polynomial just means like a big group of terms. So in this one, we're going to be talking about exponent rules. Okay, exponents might not be something we've talked about a whole lot yet this year, but exponent rules specifically, right? We know that exponents are just these little numbers, right? When a number is raised to a power. Just before we jump in here, just really quickly, just going over some terms. So when I say these words, you know what I'm talking about, right? So this big 4 out in front, you might have heard this word already, but it's called the coefficient. And coefficient just means like it's a number multiplied by a variable, right? So it would be the number out in front of the x. You notice that none of these have coefficients on them, and that's okay, but the examples that we'll do later do have coefficients. And then the actual, so there's two words having to do with exponent. Okay, so there's the base, okay, and then the little number itself, the 2, is the actual exponent. Okay, so an exponent is just a little number, okay, and again, I'll explain what that means. And then the x is, again, the base, okay. Okay, so now getting into these examples, okay, so it just says look at the examples below, and we just need to kind of, it doesn't say it up here, but we're going to simplify these, okay? It's kind of saying multiply these together, and this one's saying divide and simplified, okay? So let's talk about how we would do that, okay? So this first one says x to the 4th power times x to the 3rd power. Again, you might remember an exponent tells you how many times you're multiplying the base times itself, okay? Or basically how many of this base, how many of those we're multiplying together. So like x to the 4th power would mean, like if I'm expanding that out, that would be x times x times x times x, right? 4 x's multiplied together, 4 bases multiplied. And then the x to the 3rd term, again, that's just saying x times x times x, right? The base multiplied by itself 3 times, okay? So then thinking about what this is saying x to the 4th times x to the 3rd, okay? So between these two as well is it's being multiplied, okay? So basically what I have here is now one long chain of multiplication, right? So there was 4 x's multiplied, and now there's 3 more x's kind of multiplied, kind of added on to that chain, right? So I would think, okay, how could I write this as like a single term, right? Because it was 4 x's multiplied times 3 x's multiplied. Now I have a total of how many x's multiplied together? 7, right? 4 and 3. So I could say 7 x's multiplied, or again, kind of taking that back to the shorthand way of writing it, x to the 7th power. Okay. So that's a way I could write that. Again, that's a lengthy explanation of it, but that's what's happening there. Okay. Now this next one, kind of that same idea. This next one, I have just x. And again, something that we've talked about. This x has, again, the standard for an x is that it has a 1 exponent. So when it doesn't have an exponent written on there, we say the exponent's 1. Okay. So this would be saying just 1x, x to the 1st, times x to the 6th power, which means 6 x's multiplied together. So again, and it's being multiplied, these two, right? So it's times x times x times x times x times x times x, right? So 1x times these 6 x's, and again, same idea. How could I write this as kind of a shorthand way of writing it, right? Kind of unexpanding these. I would have a total of 1x, and then these 6 x's gives me a total of, again, x to the 7th, okay? Or 7 x's multiplied in this big chain. Now, what I would want you to work towards is a shortcut, because it's annoying to have to write out all these x's every time, right? Now this last one, this is where I don't want to have to do it, right? Because when we see y to the 7th times y to the 29th power, I don't want to have to write out 29 y's in a big list like that. That's too much, okay? But thankfully there's a shortcut here, right? And you might have already noticed it, right? Like if I wanted to cut out this middle step and just say, okay, how can I go from this right to my answer? What could I do? And again, you might have noticed, you might be saying it in your head already, you can add. If you add the exponents together, that's kind of the shortcut to prevent you from having to expand it out like this every time. Okay, so the shortcut is to add the exponents, right? So basically, like if we have something, some base raised to a power, times that same base. Okay, so that's the key. The bases have to be the same to be able to do this. But if there's the same base and they're being multiplied, I can add those exponents together. Okay, so like in this case, thankfully, I don't have to write out all these y's. I can just say, okay, y to the 7th times y to the 29th. I could say, okay, that's the same as y to the 7 plus 29 power, and 7 plus 29 would end up being 36, so y to the 36th power. Okay, so that's the shortcut there. Okay, so that is the multiplication rule of exponents, is the fancy name of it, okay? So that's one exponent rule that we'll go over. Another exponent rule that we'll go over has to do with division, and you might guess with this one what it might be like and what the shortcut is. But just, again, showing what this is about, the same idea, okay? So if I had x to the 10th power, again, just like over here, x to the 10th would be saying 10 x's multiplied. So if I had 10 x's on the top divided by 7 x's, or x to the 7th, right? Okay, think about this, right? If I'm dividing x to the 10th divided by x to the 7th, that's what I have, this huge big fraction with all these x's, okay? What happens when you divide something by itself? When you divide something by itself, it cancels out, or it would equal 1, right? And so that's what we think about here, okay? So like this first one, x divided by x, that kind of cancels out, right? X divided by x cancels. Now it's going to happen a bunch of times, right? X divided by x, x divided by x. So a whole bunch of x's canceled there, okay? But then eventually I do run out of x's on the bottom. So I look at, okay, what do I have left now? And what I have left are these 3 x's on the top. Or again, how could I write that in the exponent version? X to the 3rd power, right? Again, I didn't write all the little multiplication signs in there, but it would be there. 10 x's multiplied together, 7 x's multiplied together. It'd cancel out, and I'd have left 3 x's multiplied together, or x to the 3rd, okay? Now, same idea for this next one. Y to the 6th power, so 6 y's over 2 y's. Same idea, right? I can just take this and, again, cancel out what's the same on the top and bottom. So 1y, 2 y's, cancel. I'm out of y's on the bottom. So now I look and I have 4 y's remaining on top, or y to the 4th, right? So that y to the 4th is what's left after I cancel, okay? Now again, hopefully you've been observing this and seeing, oh, what's my shortcut? Because there is a shortcut here, right? Because again, when you have big exponents, it's really annoying to have to write out 32b's. But let me just say this. Some of my kids, I show them this way and then I show them the shortcut. Some kids still really like to just write out every letter and do the crossing out, and that really helps them. So if that helps you to get it correct and you're still a little bit iffy with the shortcuts, then just write it out. Take the extra time, right? It's important in math to do what you need to get it correct, okay? And so if you need to write out every letter on there, awesome, do that, okay? But again, there's a shortcut, right? As you can see, how could I go from here to here with kind of skipping this expanded out step? It's just the opposite of the other one, right? The other one I added the exponents, right? These ones I can subtract the exponents. Okay, so for this one, like if I have x to the a power, or just x to some power over x to the b power, again, the key is the bases have to be the same. But if that's true, if the bases are the same, then yeah, we can just subtract the exponents, and we don't necessarily have to write out all those x's. Okay. So again, in this case, b to the 32nd power, or 32b's, over 11b's, and a bunch of them would cross out, right? But again, what I can do instead is just do b to the 32 minus 11. 32 minus 11 would be 21. So b to the 21st power. So those are the little rules for you, okay? What I'm going to do here is erase these, and I'm going to just do a few examples with you where we can apply these within like bigger terms, okay? All right, guys, I've got a bunch of examples up here. We're just going to go through these 5, and that's it, okay? So just jumping into number 1. Again, the directions say simplify these using the multiplication and division exponent rules. Again, those are the ones we just went over. Again, don't get confused. They're called the multiplication and division rules because we use them when we're multiplying these terms with the exponents. But again, the shortcut is not to multiply or divide the exponents. The shortcut is to add or subtract the exponents. Okay, so it's easy to mix those up. So just don't be confused by the names there. Okay. Now, with all these, you'll see that I've added coefficients, right? I've added these numbers out in front of the variable. So we're going to talk about how we deal with those as well. Okay. So looking at number 1 here, they're saying 3x squared times 7x to the 4th. Okay. So again, if we just going with what we learned right now, let's ignore those coefficients and let's just think x squared times x to the 4th. Okay. And so I'm able to do that, right? I'm able to kind of separate it and say, okay, x squared times x to the 4th. So again, applying my exponent rule, I would say, okay, x squared times x to the 4th. Adding those exponents together, 2 plus 4 would give me x to the 6th. Okay. So x to the 6th is how many x's I would have if I would multiply these terms. Okay, but they have coefficients as well, right? So kind of separately from the x's, I would do 3 times 7, right? Those are the two, right? 3 is the coefficient of this term times 7 is the coefficient of this term. So I would do 3 times 7. You guys know that. 3 times 7 is 21. Kind of putting those two parts together, 21 and the x to the 6th, that would be my final answer. Okay, so it'd be 21x to the 6th power. Okay, so you kind of separately, you multiply your coefficients and then your variables. Okay. Now the second one, same idea. It's 20y to the 5th divided by 4y. Okay, so for this one, same idea. I can kind of even separate it into two fractions. 20 over 4, just the coefficients, and then y to the 5th over y. And again, you can add this in there when it's just plain old y. There's a 1 exponent there. Okay. So kind of simplifying this, 20 divided by 4, again, those are just two normal numbers, so we divide those like normal. 20 divided by 4 would be just 5, right? And then y to the 5th divided by y to the 1st. Again, I subtract my exponents here. So 5 minus 1 would be 4, right? So again, and then I just lump them together. 5y to the 4th would be my answer here. Okay. So my kind of what I like to say to my students in class to help them remember, because it's easy to mix up, right? It's easy to multiply these instead to get 8 as the exponent, or like divided by 1 to be 5. Because you're kind of like when you have coefficients, you're kind of doing multiplication and addition within the same problem. So it can be really easy to mix up, like, oh, when do I multiply? When do I add? All that stuff. Okay, so here's my saying as I like to say. With multiplication problem, I like to say multiply the big numbers and add the little numbers. Okay, so the big numbers would be the coefficients. You multiply those. So multiply the big numbers and then add the little numbers, add the exponents. Okay, and then division, it's kind of the same, but divide the big numbers, subtract the little numbers. Okay, so those sayings can be helpful to say to yourself as you go into one of these problems, and it can be helpful to check yourself after you do the problem too. Okay. Now, looking at number 3, a little bit more complex. Okay, these terms have more than one type of variable with them, right? So with this one, I have 5 times 10 as my coefficients. And again, it helps here that you have this big complicated problem. It helps to just break it up, right? So my coefficients first, 5 times 10. And I can multiply those. 5 times 10 is 50, right? That's easy. And then my x's, right? So look, I know I have x squared here and y cubed in this term, but I can't multiply things, right? Those aren't the same base, right? So I wouldn't add those exponents together because this base is an x, this base is a y. So again, that rule is the multiplication rules, or these exponent rules apply only when they have the same base. Okay, so I look at this term and I say, okay, that has x squared. Then the second term just has this single x, or x to the 1st, right? So because this now has two x's, right? There's these two separate x's. I can multiply those two together. Okay, so it'd be x squared times x to the 1st. Again, the shortcut. Add the little numbers, add those exponents. So it would be x to the 3rd. Okay. And then lastly, my y's, right? Y to the 3rd in this term. Again, you look for the same base here, right? Y squared. So y cubed times y squared. I can multiply those, add the exponents to get y to the 5th. Okay, adding those little numbers. And again, my final answer is just putting all those together. So 50 x cubed y to the 5th power. Okay. And again, saying like you're hearing me say to the 5th power, that's the same as like a 5 exponent. Okay, two more. One big division one here. So same idea. 48, a to the 4th b. Again, that has a 1 exponent. I'm going to include that right now because it's easy to forget. And then 6, a b to the 3rd. Okay, or a to the 1st b to the 3rd. Okay, so it helps as you first read through the problem, add those little 1 exponents in there with any variable that doesn't have them. Okay. And then now again, what's helpful is I can just separate this into 3 separate fractions. Okay, so 48 over 6, my two coefficients, a to the 4th over a to the 1st, and then b to the 1st divided by b to the 3rd. Okay, and that last part's going to be interesting. We'll talk about that. Okay, but just going down the line here, so 48 divided by 6, and that would be 8. Okay, and then a to the 4th divided by a to the 1st, so subtract those little numbers. 4 minus 1 is 3. And then look at this one. This is interesting, okay? We're not going to talk about negative exponents right now because that's a little bit more complicated of a problem, and we'll do that later in the year, okay? But there's 2 ways that you could write this, okay? It's actually interesting. B to the 1st over B to the 3rd, okay? So I have these two, right? And if I subtracted 1 minus 3, I would get a negative 2 exponent, right? If I did my subtraction rule, 1 minus 3, yeah, that would be a negative 2. So this is one way you could write your answer, okay? But it's going to look different. So think about this. It's going to look different if I do my, like, kind of my expanding. So let me write this problem another way. Okay, so look, I expanded it all out here, right? I took 48, a to the 4th, so 4 a's, b to the 1st, so just 1 b, 6 a, and 3 b's, right? B to the 3rd. Okay, so if I did it this way, look what would happen, okay? One of my a's would cancel, right? Because that's the same on top and bottom. But then there's no more a's to cancel. And then one of my b's would cancel, and then there's 2 b's left. But look, those 2 b's are left on the bottom of my fraction. Okay, so that's actually what a negative exponent is. Okay, but again, we'll talk about that more later on. But, and then I could do 48 divided by 6 to still get 8 again. But if I was to write it this way, I could say 8, a to the 3rd over b squared. Okay, this is another way I could write my answer. That's the same as this. Okay, so again, we'll talk more about negative exponents later on and all that, but just know that depending on how you did this one, you could get 2 separate answers, and you might be like, whoa, that's way different. But it's not, okay? And for right now, with where we're at in Algebra 1, if you leave your answer like this, it's totally fine, okay? Now, lastly, looking at number 5, 6xy times 2x squared times 3y to the 4th, okay? Now, again, really complicated. We got three terms that we're multiplying here, and you might notice that some of these have both x and y. This middle one just has an x, and this third one just has a y. So it's going to be a little bit weird, okay? But again, same idea. I like breaking it down like this, okay, just to help kind of take a really big, long multiplication, kind of break it down a little bit. So again, I could just do the coefficients. So 6 times 2 times 3, just my big numbers. So 6 times 2 times 3. So I could do 6 times 2 is 12, and then 12 times 3 is 36. Okay, so my coefficient after I multiply all these is going to be 36. And again, those are big numbers. So that's why I actually did the multiplication there, right? Multiply the big ones, add the little ones. Okay. Now for my x's, I have this x to the 1st, and then I have this x squared. So I'll multiply those two. But again, this one doesn't have an x. So I'm just going to multiply 2 different x's together. And that's fine. That's less work for me to do, right? So x to the 1st times x squared would be x to the 3rd. Okay? So it's okay that this one doesn't have an x as well. I can still multiply. And then this one, same idea. Y to the 1st, right, times this last one, y to the 4th. So again, adding those exponents, 1 plus 4 would be y to the 5th power. Okay, so kind of writing this as a final answer, I would have my 36 coefficient, x to the 3rd, y to the 5th. So that's what I'd be left with on that big one there. All right, guys, hope that made sense. Thanks for following. I know it's a longer one, but awesome.